Going to manual.
Oh, nice save!
Hey guys, it's been a while since I've done any videos or really updated anybody on what I've been working on, so I figured I would go ahead and do a series of videos on this latest project. I really didn't do a build series. I really didn't record anything as I was building it, but I'll go ahead and walk you through some of my thought process and how I built this, and then we'll talk about testing. And I have some testing footage, and I'll probably do a whole series of videos on this as I progress through testing and experimentation with it. And this really is a research plane. Basically, I wanted to look at VTOL, vertical takeoff and landing. And so I figured this would be a good test bed. It's built modular. So if I want to change the wing design, I can take these wings off, just make new wings and slide them on. So let's go ahead and take a look at this. Now, I've tentatively decided to call this the Rogue. And really that's because early on in the testing process, it really had a tendency to kind of do its own thing. So I thought the Rogue was a fitting name for it. This is a VTOL, vertical takeoff and landing. It is a tilt wing VTOL. And more specifically, it is a tilt wing tricopter, non-vectored yaw. Got all that? Okay. All right, so primary construction is hot wire cut EPP foam. We've got a 3D printed motor camera mount up front with a Foxeer Predator Mini in it, so that I can record DVR with all of my telemetry, real-time telemetry. Also, so I have that coming back on the screen. The fuselage, pop this open. The fuselage is made of this hot wire cut EPP segment. So basically these little quarter moon segments, I cut 4 of them and glued them together around. And basically we have a 4-inch by 4-inch center volume. And then we've got the full round on the outside. And that's pretty much the fuselage construction. It's EPP with white Gorilla Glue that was all taped and pinned. And then I've got 3mm lam over it. No spars in the fuselage at all. And this construction technique, I've used it on a couple other big planes. Works really well. It yields a really rigid yet forgiving structure. Pretty light because there are no spars in it at all. The wing construction is hot wire cut, EPP as well, with 1 or 2 fiberglass spars, top and bottom, laminated. This is a NACA 23015 airfoil on the main wing. And the main wing tilts, so this is a tilt wing VTOL, and don't mind the mess of the wiring underneath. It's a prototype, so you know it's not going to be the neatest, and things change quickly, and I don't spend a lot of time making the prototypes look good because, you know, honestly, they may not survive the first flight. So powering it, we have some Sunny Sky 2814 1250 kV, which is kind of my motor of choice on a lot of my builds, specifically this size. We're spinning APC 10 by 5.5 multi-rotor props. These are giving me better thrust for vertical, and they're probably not the most efficient for forward flight, and I picked up a motor test stand, and I've been doing some testing on different props, and I will probably go to the APC 9x6 prop. Not as much thrust coming out of, in the vertical flight, but I'm getting better efficiency in the forward flight. So let me back up. One of the design principles I wanted to explore with this VTOL project is really maximizing efficiency, minimizing dead weight or weight that is only used for one phase of the flight. So there are different configurations for VTOL. I could have gone with a fixed wing and then 4 quad motors, which would give me, I think, better control in the vertical flight because of the quad configuration as opposed to a tricopter. The motors could have been a little bit smaller in that, they're not having to lift as much, because there's 4 of them as opposed to really 2.5 here. Forward transition would be a little simpler, I think, but me, I don't like to do anything the easy way, so I figured I would complicate the hell out of my life. So by going in this configuration, these motors are doing double duty. Yes, they're probably quite a bit bigger than what I would normally have needed on this. During my initial forward flight testing, I was actually using what I had laying around the shop, which was 20 Sunny Sky 2212 1250 kV on 8x6 props, which were more than ample for forward flight. They were pretty efficient, but they lacked enough thrust in vertical flight. Not so much initially on takeoff, but on landing, as the batteries start to, as our battery voltage starts to come down, they were really suffering, especially when I put a heavier battery in. We're chasing that whole weight thrust thing, and I was really having a lot of problems with those. So after the initial forward flight, ground testing of forward flight, I went with these 2814s. And the other thing I did with these is I extended the motor mount to help with balance. So right now I have my main tilt spar running through essentially the 25% MAC, the quarter cord on this. And there's, in something like this, balance is everything, and CG location is everything. So by extending these motors and putting them out front, when they come down in this particular configuration, it slides the CG forward because the weight of these is forward more. Then when we rotate up, this mass, this fairly heavy mass, comes back a little bit, and now we're shifting the CG back, which is better for this. So now we're sharing, probably 3/4, maybe 7/8 of the load on these 2 front motors, and then a little bit back here on the rear motor, so that we do have some authority to move backwards. We are, tail heavy in this configuration, gives a little bit better control in the hover. You can see we've got 2 fixed portions of the wing here, and inside we have the twist pivot spar that runs all the way through. We'll take a look at that in a second. And that has bearings actually inside and out. So that carbon fiber tube is sitting inside a bearing. So when we do have a lot of load, especially in vertical flight on these wings, they're easy to rotate because they are on bearings. The landing gear are 3D printed with a control rod in them right now. Originally, what I had were legs landing legs that were glued on under the motors, and the idea there was, I only need them when the wings are down. And I was thinking that if I ever got into a situation where I needed to belly land it with the wings, in the up configuration, that landing gear wouldn't get in the way. What I found was, especially early on when I was using a different pivot system and a smaller spar, is that the repeated banging, which there was a lot of banging when I was first learning to hover with this, was actually putting, with that, legs out here, was putting a lot of stress on this main spar, and actually initially the initial spar snapped on me. So the initial pivot tube. So I'm using a much larger 16 millimeter pivot tube now. And then what I ended up doing was moving the legs inside. The other thing that was happening was, when you're bouncing, what would end up happening is that these motors, these wings would get slightly out of line, which would then induce a yaw effect. And the tail was having a hard time keeping up with that. If we take a look here on the wing, I have the outboard ailerons, but at one time they actually came all the way in here. And what I found was, with Autopilot, at least I haven't found a way yet, when you're in vertical mode, hover mode, the ailerons are still active. And what was happening was, because there was aileron in the prop wash, every time I'd roll to one side, the ailerons would still act, and it would induce a yaw in the opposite direction, which made early hovering attempts rather interesting. So what I decided to do was just shorten up these ailerons, put in a new piece of foam, which still needs to be laminated, and I have got way more roll control than I need. I mean, these could probably be half the size they are now, and I would still be fine. Moving back, we'll take a look at the tail section. So, like I said, I wanted to minimize dead weight, or weight and components that only worked in one of the flight modes. The tail rotor is the one piece, aside from maybe the large servo, that really doesn't have a purpose in both flight regimes. The tail rotor is only for vertical flight, so what I wanted to do was minimize its size and its weight. And more importantly, I wanted to minimize its drag. So that's kind of, the theme of this was minimizing drag during forward flight. So I didn't want the 4 quad motors hanging off the side, causing drag. So that's one reason I went the other way. The reason I went with a tilt wing instead of a tilt rotor is that with the rotors tilting up in a tilt rotor design, half of your prop disc is pushing down on a flat wing, whereas if we tilt the whole wing, that the rotors are much more efficient in vertical flight because they're just pushing that air across that airfoil, so we're getting a lot less losses there. The downside of that is that with the wings down like this, we've got this huge sail, so hovering in the wind can be challenging. So right now I've been focusing on getting it into the air and getting it transitioned as quickly as possible. Still working out exactly how we want to hover it in the wind. But back to the tail here, I really wanted to minimize the effect of this tail rotor in forward flight. So what I did was I'm using a very small, light multi-rotor motor. It's a 1407, I think. 1306 or 1407. It's small, running a 3-inch prop on it. And I found that it is more than enough in the back. It is mounted upside down right now. Early on, I had it mounted on top, and what I found was, as this motor is tilting side to side to vector the yaw, what was happening was all of the thrust was hitting up against the inside of the duct here and being deflected down, so I wasn't getting as much yaw authority, and I was getting more pitch out of it than I wanted. And the simple solution was just turn it upside down, and that seemed to work quite well. I may reprint the mount that it's on and drop it down a little more, get a little more efficiency out of it, but then I'm going to start getting into some extra drag in here. I went with the VTOL simply because it gave me the ability to nestle this lifting motor, this third motor, tilt motor here in the back, and be, fairly streamlined and efficient during forward flight. So really trying to minimize the impact of this. Like I said, it is one of the only components that does single duty on this. The ruddervators here are actually pretty small, and I was concerned that I wasn't going to have enough elevator and rudder authority, and what I found during flight testing is that I have ample control. Elevator control, and you'll see in some of the videos, is quite good, and yaw control isn't bad either. So I guess next I'll pop the top off and we'll take a look inside and discuss some of the decisions I made inside. Be nice. It's a prototype. It's not the neatest thing in the world. My wiring skills leave much to be desired. Okay, so we've got this set up here so you can look down inside, and if I pull the bay cover here, you can see that that's just held on with a little lip here, and a couple of steel pieces just catching, a couple of magnets here. Okay, so up front, in the front here, we have the Maytech F765 wing board, and really liking this board. Jury's still out. I'm not loving the current sensor on it. Has been giving me a lot of problems, and I haven't been real happy with that. But the overall board is fantastic. I have a remote USB connection here that I picked up from Ready Made RC, because constantly plugging into it, I actually ended up breaking the USB connector and had to solder a new one on. Coming back underneath all of this mess, the ESCs are down underneath the center here, and then their wires come up, run into this tube here. So this is the pivot tube, and basically the way this works is, this is actually surplus from an old multi-rotor I had, a large 650 size multi-rotor. And they are 16 millimeter carbon fiber tubes that come into this connection, which is actually just a motor mount, believe it or not. So then there are two tubes, and the reason I did this was that I could play with alignment for one, but also I could run these motor leads and servo leads inside the tubes out. And then not have to worry about how to deal with them during the transitions. So they run inside the tubes and then are distributed to either the motor or the servo in the wing. What I have here is a large servo that is the tilt servo. And then this tilt servo, I made an aluminum mount that bolts to the bottom here. So as this servo moves, it tilts the wing. This servo here is actually a locking mechanism, so when this wing rotates up into forward flight, to minimize any flutter, basically, this servo would just turn and it pushes a pin into here, into the wings, to keep them from rotating and fluttering and vibrating. I haven't tested this in flight yet, just because I'm nervous that I know it will lock, but I'm afraid if it's under too much pressure in flight and it won't unlock, I won't be able to rotate the wings back and things will get interesting. Okay, so moving back, I have mounted here a Crossfire Nano receiver here with the antenna here on the wing. Not optimal, but it's not going far enough range for it really to make a difference. On this side, I have an adjustable VTX. This is 25 to 6 or 800 milliwatts adjustable VTX. I think this is a Mach 3 VTX. Coming back, you can see on the bottom here, I have actually some steel tire weights, just trying to playing with shifting some of the weight back, because the battery actually goes up in here in the nose. And as I get bigger batteries in there, I'm moving the CG too far forward for the vertical flight, so I counteracted that putting some weight in the back, which, you know, isn't ideal, but during this development period, it's not killing me. Right here, this is interesting. These are 3D printed gears, and there is a servo here, and this is the tilt servo for the motor in the back. So basically the servos here transmit the twist up here to a carbon fiber shaft, which is actually just a carbon fiber arrow shaft that comes to the back here and tilts the motor. Again, we're riding on bearings that are mounted 3D printed slots. Recesses are set up for the bearings in here, and the shaft just runs through those bearings. The idea here was twofold, actually. One, I wanted to get the weight of this extra servo out of the tail. I wanted to move it as far forward as I could so that it wasn't having so much of a tail weight effect. The other reason too was I knew that once I got everything in here, it was going to be difficult to modify or repair if the servo went out. So by having it up here and not buried inside the wing, I have access to it. So it's much easier to replace this servo and these gears. Honestly, there's just not a lot of stress on them. The gears are printed in nylon X, and you know, I've been testing this and putting it through hell here for the last month or two, and they really don't see any wear on them. So pretty happy with the way that's been going. GPS mounted up here. Tried to get it as far away from the other stuff, but part of the problem with this is, you know, a lot of times I would mount things out in the wings, and then that just complicates the wiring getting them out here in the wings. So most of the electronics and the radio and everything were mounted in the fuselage, but again, this isn't the final product, and it's not a real long-range bird at this point, so it's not really giving me any problems. The wood in here, the formers and the supports for the wing and everything are all modeled and then milled on my Shapeoko CNC router. The foam that goes with all of these wooden inserts here on the wings. The foam is a CNC hot wire cut that I have here that I built a few years ago. These pieces here are the tube clamps. Essentially, they glue into the wing. The spar glues into them. So I get a very rigid wing, and then the carbon fiber tube slides in, and then there are two set screws. You can see that it wasn't holding quite well enough, so I actually broke down and threw a screw in the top. I'll probably design these with a key next time, but I didn't want them to be able to be adjusted. But by going with this configuration, I have adjustment here in the center, so really I can key these and not have to worry about them, and then really just worry about my adjustment here in the middle. And that's pretty much it. Okay, so if you guys have made it this far in the video, I really appreciate it. This is, I think, going to be a series on the development of this. They probably won't be nearly this long, and I will try and keep the talking to a minimum unless you guys have questions that I can't answer in comments. If you do have questions, put them in the comments. I will try and address them in the next video. So with that, I will catch you guys on the next one.